So I've been taking a little bit of a break from dev for a bit, just kind of chilling, playing games. But I have something I've wanted to work on a while. So a long time ago, I did a particle-based nebula, but I want to try doing one with ray marching because we have a lot better understanding of that now, and we also have this cloud function we built, um, which includes a lot of stuff that we do not need. For example, we don't need any of this atmosphere stuff. So we basically want to adapt our existing code from our atmosphere and change it a bit to work. God damn it. Change it a bit. Okay, main image is fine. We'll get rid of this. And we want to just make a much. It's actually going to be. It should be simpler. We shouldn't need this. We shouldn't need this. We shouldn't need any of this. Don't need this. All right. So we actually thinking about how we need to do this. So with this, rather than being a post-process effect attached to the camera, it's going to be something that we want to be able to place locally in um, in the scene. So the way we calculate it, it's going to be a bit different. I almost want to just start from scratch, but we're going to take the world position, and that's going to be our ray start point, and then we'll need our vector parameter light position, and we'll need our camera position. Okay. Um, and then we're gonna have camera direction and light direction. All right, so what are we doing here? So rather than in our cloud atmosphere thing, we had to define our whole sphere. But in this, we don't actually need to do that. What we need to do is define our entry and exit points. Our entry point for a given point in world space should just be the world space position. So like if we're talking about the point at which our camera enters the thing. So if our camera is here and we have rays coming from the camera. God damn it. There we go. And rays coming from the camera. The point at which you want to start tracing is just the world position of the surface, right? And the direction is going to be the world position minus the camera angle. And I guess we do need a sphere trace. All right, all right. So we do need a sphere trace. This we can get rid of because we're not dealing with a shell anymore. We were doing like a shell trace, but we're not going to need that anymore. We're also not going to need this height coefficient, but we'll need something like it. And we also don't need this shadow factor. I'm going to keep this phase function though. Our noise formula will change, but for now we're just going to get our existing noise formula working. This height coefficient isn't a thing anymore, so get rid of that. Okay, light march looks correct. Cloud march would be star position, step size. I almost want to start from scratch. Yeah, let's just start from scratch. We'll keep this as a reference. But I think it's going to be easier to just code it from scratch. No, 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 no. VS Code, please. There we go. Why don't I put on some music that won't get me copyright struck? Let's do this one. There we go. All right. Coworker too. Okay, today we are going to work cell applied to material. We will assume say ray sphere intersection form raymarched textures. Textures as well as the light position, camera position, and surface fold. to do anything yet. I'll have questions in a bit. Start. Let's just create a quick placeholder here. Get it started with that. Silence. No, I don't want to do that, and I don't want to install the update because this is the one that works well. Okay, nebula functions, tab, 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 do this, do that. Alright, so thinking about how we want to handle this. Do we want to do a ray sphere that returns the positions? Or do we want to do a ray sphere that returns the intersection and transmission distances? I honestly think that returning the positions is easier to work with, so let's say or we could just do like a full featured one that does everything. So it would be float 3, ray, direction, float, first, intersection, distance, add in float 2. First intersection, 3 second intersection, pool is inside, something like that. I'm just thinking, like, we may not need all this. Name it output because we didn't want to name our function intersection. Okay, actually, let's go see what coworker had to say. Okay, so in our old function, it was a post-process volume, so our intersection sphere was defined purely via code, HLSL code. In this function, it will be a non-post process material applied to an actual object. So I think our first intersection point will always be the world position value from the material. We then need to figure out how, using that value, using combination, that value, the camera position, the light source position, value in the camera position, to determine the exit position of the ray from the object. For simplicity, we can I'm not sure if it may be possible to make this work for a regular shape using existing material information. It's a custom depth or interpass that writes out the depth from the perspective of the light or another relevant object. If possible, within material to determine if a point in space within the object's mesh, or perhaps, if not, we could potentially custom pass with flipped normals so that the back side of the shell is rendered and then use that information. It doesn't seem to work. seem to have... How can I create a filter to render patterns? Maybe easier to just use a freaking, it may be easier to just use a sphere. I don't have to do multiples, you know what I'm saying? Like, because it's really expensive. So it'd be better if I could create like a custom shape and have it render just inside. Check if raymarched position is inside object. Check if position is inside object in material UE5. We could just use a sphere and then use our noise functions to determine our overall shape, which might actually be the way to go. Alright, let's think about doing it that way. Skip a bit. Okay. Okay, let's just start with the assumption that it's a basic sphere, and maybe we can utilize the noise density function itself to create the shape. Okay, so given a world position on the surface, the sphere, a camera position, and a camera position, how can we determine the segment we need to raymarched across? It's going to be a sphere trace.
Today, through the stars, battle won. Astra Militarum, Wilkins and none. Soldiers of the Imperium stand tall. In the void they heed the call. Through the darkness, through the pain, Astra Militarum will remain.
I thought we need a sphere intersect. Already have a desired output struct to use the fray. In his name they fight today. Through the stars, battles won. Astra Militarum, second to none. Soldiers of the Imperium stand tall. In the void they heed the call. Through the darkness, through the pain, Astra Militarum will remain. In their hearts, duty's flame. In the void they stake their claim. Through the war they hold the line. Astra Militarum ever divine. Soldiers of the Imperium stand tall. In the void they heed the call. Through the darkness, through the pain, Astra Militarum will remain. Will remain. Will remain. In the trenches, courage found. Astra Militarum, duty bound. Through the fire, through the fight, soldiers stand Let's
with all their might.
make our ray
Soldiers
sphere
of the Imperium stand tall. In the void they heed the call. Through the darkness, through the pain, Astra Militarum will remain. Banners high in the fray. In his name they fight today. Through the stars, battles won. Astra Militarum will remain. Banners high in the fray. In his name they fight today. Through the stars, battles won. Astra Militarum, second to none. Soldiers of the Imperium stand tall. In the void they heed the call. Through the darkness.
awesome. So now we'll take this.
Astra Militarum will remain. In their hearts, duty's flame. In the void they stake their claim.
Reorigin, redirection.
They hold the line. Astra Militarum, ever divine. Soldiers of the Imperium stand tall. In the void they heed
So now we're going to need some values here. We're going to need flip 3, ray, camera position. Let's use caps for globals, and then float. We knew we would need these. We're also going to need excuse me. Alright, center and radius. Now we need our first inputs here. Camera position, world position, light position, center, and radius. So, position, world position, light position, center, radius, vector position, light position, world position, camera position. Alright, there we go. Now we got these. So now we can do ray direction equals world position minus camera position. Normalize. Test output equals calculate ray sphere intersection. I do not like that name. Just ray sphere intersection here. And this is going to take ray origin as camera position, ray direction, center, radius. Alright, and now we're just gonna do so Dot dot intersection point one. All right. This is some weak ass like spelling issue here, probably. Why are you highlighting the whole thing? Just double click should highlight the word. Oh, I'm missing a. Yeah, okay, that's it. Boom. Boom. Intersection point one, intersection position one.
Candles lit, prayers spoken, in their hearts never broken. Through the fire,
Alright, so far so good.
pain, sisters stand in his name.
And that's the backside. Alright, great. Well, it is two-sided. So if I do this and I go inside of it, we'll have to figure that out. But for now, we're good. Okay, so there we go. Race for intersection. Okay, so we need another one. It's gonna be their function here. Float, sample, density. Just thinking, because we may want color control. And what we're gonna do is just start off. Just gonna start it off with a texture. Texture objects, BT, Illinois to start with. I need to look at the sampler over here. Texture 3D sampler state. Okay, that's great. That's all we need. Texture 3D, volume noise. Texture, I don't know, sampler state. Sampler.
Shattered dreams in the void, silent screams, horror's mark forever stained in his name.
Enough volume, noise, volume, noise, volume, noise, sampler, noise sampler. Alright, and to start, we're just gonna have an extremely simple, just a single sample here. So next we can take let's just do this for now. Sample density based on our first intersection. Use our radius as the scale. Beautiful. Make sure we just plug this in, and then roll position. This is so that we can verify. Trust but verify, right? So I don't think this is actually the correct Voronoi. Oh yeah, and then this has got to be divided by the radius. Yeah. So this is the wrong one. this one. There we go. Now you have lots of channels to work with this one, right? And then I bet, perfect. Okay, so we've successfully recreated a texture sampler. But that's step one. What's up, dude? What's going on? So a while back I did a nebula, but I used a particle system to like fake volumetrics. But I understand a lot more about raymarching now, so I'm trying to basically make a better version of it that uses raymarching instead of faking it with a bunch of particles that all turn to face the camera, which leads to like artifacts and stuff. Whereas if you do it with true raymarching, you should have just a consistent effect. Alright, so now we have our density sample, or at least a basic density sample. We have a ray sphere intersection. Both are working. We know both are working because we can test it. Because if I was to... because we're using... Oops, what did I just do? No, don't do that. We know they're working because we can test it. For example, let's do this. Float 3 density test equals this. Do that, we get our texture, but if I was to just do this, we can check our intersection points from our ray sphere, which is going to determine the bounds that we march through with the ray marching function. So we can see this looks right for our world positions on the surface of the sphere, right? And that's our first ray sphere intersection. And if I switch this to 2, it's the back side of the sphere, basically like the back faces. So I think our positions are correct. So that's the start. Customizable color for clothing. I'm trying to do my material for customizable color for clothing on my character. What kind of challenges you running into? Yeah, and I may have a little bit of time in between responses because I'm going back and forth between looking at chat and coding here. Let's see. So now we know we have our test output here, so we're gonna need a float 3 raymarch. We can probably just pass this our ray sphere output struct. Intersection to raymarch. That's kind of long. Intersection. Oops. So float 3 ray march, we're gonna need another one. Float 3 light march. We can get to light march probably tonight. All right, so to ray march, we basically want to march from our first intersection to our second intersection. So, so we need to know a few things there. We need float, float ray. We probably want to have a standardized step size because I've ran into issues with trying to like have ray-based step sizes. It leads to some inconsistencies. So we'll probably want to do our step size as a function of our radius. So like float step size. Let's do it like this. Fine. Hashtag fine. I don't remember the format for this. Let's look at our other function. Okay, I was right. Define max steps. Let's do 200. Step size equals radius over max steps. Right, so let's think about this. So our start position will either be float 3 start position equals intersection dot intersection position 1 if intersection dot restart inside sphere start position equals intersect. I spelled this wrong. Section dot restart position.
In his words, we find our way in the void, night and day. Ethereal stream, shining bright in the void. Our endless
3 in position intersection intersection position 2 in position equals intersection dot intersection position 1. Float max array length equals length of start position minus end position. Embroidery decal. I'm trying to clamp the okay, let me see. I'm trying to clamp the mask of the texture, the borders on the bottom of the square. Embroidery decal using 2D array for them. I'm trying to clamp the mask of the texture to the borders on the bottom of the square. I'm not 100% sure what you mean. Yeah.
walls of iron, siege begins. Emperor's realm
Textures that I'm using as a mask. Okay, sure. Place them. On the bottom of the texture. I'm not actually sure. I'd have to. It's like it's hard to get a grasp on this stuff without seeing it, I guess. Like from I'm not sure what you mean by the bottom of the texture, because like you mean like the actual like texture asset, or like the bottom of some mesh, or the mask on the edge. I mean, that would have to do with your texture coordinate then, probably. I mean, it depends on how your textures are set up, right? But if you're using like basic texture coordinates, then your 0 0, I'm not sure if your 0 0 would be the bottom left or the top left. But if it was a square, right, let's see. So like in this case we're wrapped on a sphere, right? But if I was to do this, you can see where the texture coordinate goes, right? So like your 0 0 appears to be the, hang on, it's X, Y. So we're facing the x-axis. It looks like 0 0 is top left, or is it? Yeah, it'd be top left facing this axis, right? So if you're placing your mask with a texture coordinate, then you would just put it, like you would have to figure out the offset of like how big your coordinate is relative to the size of the thing, and then stick it there with enough of an offset to push it up, you know what I'm saying? I don't know, it's like I don't actually know the answer to that without like futzing around with it, you know? That's kind of cool. It's a sphere trace on a plane. Kind of interesting effect, actually. This? No, so we're doing a ray marching texture, which is like, here, let me show you. So we'll load into, we're basically adapting this volumetric cloud ray marching texture that I made to use it to model a nebula instead of just a layer of clouds. But the way this works is instead of rendering something on the surface of the material, we basically hit the surface and then we calculate an intersect, and we split that intersect up into chunks by looping through it at a certain step length, and then we accumulate a density from a noise texture at each point, and that tells you approximately how much of the obscuring volume you've passed through at any given point of this. So like same way if we were going this way, it would be the same thing, right? We step through this, and at this point we check density at each sample point and accumulate them, into a value, and that tells us like how much material this ray passed through. And then eventually, the other thing you got to do is you might have a light source over here. Each of these points has to trace to the light source, and it accumulates how much light has reached that point given the density of the rest of the material it's passing through. The combination of those, you get like this kind of cloud texture, right, that you can fly through. It will obscure the screen, it gets shadows and things like that. So, but this is actually way more complicated than a nebula, because we're doing it in a shell rather than just a sphere. So what I'm doing right now is basically taking this and trying to adapt it to use it for like space nebula effects and things like that. Yeah, exactly. It's just an ad, but like, so imagine you have a volume noise texture, right? Then at each point you sample, you could tell what the density of the noise is at that particular point, right? And then you sum all those up, and that'll tell you the total density that that ray of light passed through. And then you have some threshold where it's a cutoff, and you just consider it fully opaque. This is way more complicated because you have to consider things like the shadow of the planet on the clouds and things like that. The one I'm building right now should be a lot simpler. This also has the atmosphere integrated into it because I'm trying to raymarch as little as possible, because it's expensive. So, but you can see where like the cone of the shadow of the planet actually darkens the clouds here and things like that. And all of that is extra stuff that has to be done beyond just the normal ray marching of the clouds. But yeah, that's what I'm working on right now. And this is just a validation that our ray sphere intersection, which is what we use to determine this line that we have to march for each pixel, is working properly. And it is, because you could tell that this almost looks like sphere coordinates even though it's mapped on a square. And if I turn it into a sphere, it's the actual sphere itself. And if I turn it into a plane, it's like a sphere projected onto a plane or whatever. It's always going to be the coordinates of a sphere, even though the object itself is a different shape, right? So coming back in here, we're just calculating the things that we're going to need to know up front. So we're calculating our step size as a function of a radius of max steps. We calculate our start and end positions of our intersections based on where we're at in the sphere. Like if our camera's inside the sphere, our start position will be the start of the actual camera, right? But if our end position would be the first intersection, because you're not going to get two intersections in that case. You're just going to get the one in front of the camera. Whereas if we're outside the sphere, our start position would be the first intersection and our end position would be the second intersection. So like this configures our start and end positions. This configures our maximum ray length after we've calculated those, and then we're going to need to, well, so current depth, start our current depth at the first step past the surface, and while current depth is less than max ray length, we will loop and basically increment this depth to sample a new point each time. And we're also going to need float 3 accumulated and accumulated density. Actually, we'll do float 2 for, or just a float for now, because this is just kind of a proof of concept. We're probably not going to finish this shader tonight. So we're gonna go float 3 current sample position equals start intersection dot actually no, we already have start position. Start position plus, let's go ahead and pull out the direction as well. So that we don't have to keep using this intersection. Start position plus direction times current, let's do current distance before we get too far with it. Alright, so like for example here, so now we've basically reconstructed a new point that we stepped through, and then we can do something like accumulated density, plus equals, we have this function to sample our texture that's just very simple right now. So we'll do accumulated density plus equals sample density, current sample position, radius as our scale, just to keep it in a like manageable scale for the moment. Float 3 density sample and we're actually, because this is a float 3 output, we're actually gonna do for now this just for proof of concept. Accumulated density, and then finally current distance plus equals step size. Three accumulated density. I guess, you know, let's keep it as a float 3 for as long as possible, and then we can just do this. And then we can just return the accumulated density at the end of the function, and then raymarched density test equals raymarch test output. Raymarch output. Raymarch output. Alright, let's give that a shot. Jesus Christ. Man, ads have really shittified the internet, huh? I see what you're saying. So you want this to align symbols at the edge of the square. I see what you're saying. So off the top of my head, I don't know exactly how. I would suggest fucking around with the UVs, the like texture coordinates that you're feeding into it. First off, try like manipulating the scale and see if you can find a way to like fuck with the UVs and make it like render at a different scale and things like that. And then try like adding to the X and Y, like go into, so looking at your second image here, where you're plugging in the UVs here, right? Try adding values to this float too. Like, try adding some range from 0 to 1 to these and see how it moves around your textures. And then also try like dividing it or multiplying it and see how that changes their scales, and you'll probably get like a feel for it. Because like that's how I like you probably just gotta brute force a little bit of trial and error fucking with the UVs to get a feel for like what changing those values does to those textures. But I bet if you mess with that a little bit, you'll start getting an idea of like how you need to manipulate those numbers to put them where you need them. Alright, so this should be our first attempt at the raymarched output here. Any errors? Yeah, I figured there might be. Control your return texture 3Cs. We just need a placeholder here. Our density's probably too high. Okay, nice. So we actually have some density going on here. Our problem initially is that our density is too high because like we're sampling 200 times, right? So what this should actually be, to avoid hitting over values over 1, would be 0.05, because you could potentially stack 200 times. This will keep it within the range of 1, but you can see how now we have like a 3D volumetric texture here on the surface, and this is being rendered on the surface of the sphere, but and then if we wanted to, we could do something like float total density, raymarched output x output we put it in the grayscale range instead of the RGB. And then the other thing we need to do is come over here, because we definitely don't need foam shading on any of this, so this can just be unlit. Oh. Okay, never mind. I think our intersection function is wrong on the interior, because like we are getting some. Maybe this should still be intersection position too. Yes. So now we have consistent behavior from outside and inside the volume function, right? Yeah, let me know if that helps, because like I said, I don't know for sure like a good answer to your question. I just know that like it probably has to do with your texture coordinates. yes. So we're gonna add a new value. So we have radius here, but we're gonna add a float, noise, scale. And we're gonna set it down here. Noise, scale. Let's do 10 to start. And then right here, times noise, scale. Yeah, so now we have something that starts to look a little bit more like a nebula. So we scaled it up. There's this kind of shitty transition from inside and outside. I don't do two-sided. Uh-oh. There's a crash. Can I recover? No. Alright, fine. I don't think we lost too much. Yeah, so I haven't messed with decals too much. I suspect placing them has something to do with the UV coordinates, but I don't want to just like tell you for sure that's the answer because like I'm a noob too, you know? I know the stuff that I've messed with. It. I might have lost the material. At least I have the function. Well, fuck. Yeah, see, I'm like I could do art, but I'm not an art guy. I'm more of a I like diving into the math. I like deep diving on like physics and shit, you know. The main, like, I don't even, I'll probably never actually make a full game with this. It's just like, I like, oh, here's how you do this physics equation in a game engine, and then you can see the results of it in real time, which is just really fun for me. Alright, so let's do, so we lost the material, but we have most of the code, so it's not that big of a deal, because that's the hard part. Um, let's go ahead and put our change in for the scale. Noise scale. Should be relatively close to what we had before. Camera position, world position, light position, center, radius, volume, noise, volume, noise. Alright, so we need some inputs. Camera position, world position. Light position. Center. Radius. Volume, noise. Picture objects. I was using Voronoi, but let's try something else. We'll do value turbulence, just for something different. Go. Let's also reduce our max steps. We don't need 200. And then, sample density times 1 divided by max steps, something like that. Except this, or no, I guess we're doing that, we can just do this. Same shit rate. Okay, and then camera position, world position, Light position. We're not using light position yet. Actor location. Object radius. Save. Save everything. So we don't have the same problem that we just had a second ago. Ah, yes, and then this needs a placeholder. Bam. Alright, we got our foggy sphere. And then we need to make this. No. Surface. Edited. Crashing? I think I saved it. Alright, let's actually look at what this fucking error is. Because it shouldn't be looping that much. Alright, well, I did save it. Yeah, it'd probably be some form of an offset on the UVs of the decal texture. I just don't know without messing with that explicitly how to make that happen. Is it got planets that you land on, or that you look at from space, or what kind of game you making? I don't know why this one would fail and the one that I'm running for my atmosphere would not, because that one is way more expensive. Should be way more expensive, so doing something wrong. While loop not terminating or something. I might put like a maximum here for sure. So like 0 iterations plus if iterations is greater than next steps, break. Save this just in case anything catastrophic happens. Smash button, party game that you hit and attack with your army. Spartans vs Persians, or make a fully character customization. Embroidery of the clothing. Yeah, I know what you mean. It's easy to get sucked down a rabbit hole, yeah. I spent probably 3 months on just clouds and atmosphere shit, and then another month on oceans, and probably another month on trying to figure out how to integrate depth into a Gerstner wave function. pissed if that material is gone though. I definitely saved it. There it is. Beautiful. Alright, so let's put this in with a hard cap on the number of iterations. Or I could just do... okay. Okay. Looks good. Alright, we're back. Sort of. Save. Save everything, please. Save all. Okay. Now I can fuck with it, and if it crashes, it won't be a huge deal. Let's take this down to... we probably don't need 200 steps. And let's mess around with some different... I'm gonna set this back to 1 just so that we can have a good look at the materials for the volume textures that we're looking at. Because this would be 1-to-1 with their like actuals. Actually, I think 2, since it's a radius, would be 1-to-1 with their like actual texture scale. So now we have like 1 block of our noise texture basically without tiling. Yeah, it takes a while. I mean, most of it is that like it's a learning process, so I don't really care how long it takes because I just like enjoy the process of learning, you know? Okay, save. This thing always shits the bed when I switch it to additives. Save everything, please. Yes. Oh, you know what? There we go. Now we're talking. Alright, that's much better. Yeah, we don't have to switch it to additive. We can use our regular unlit surface, which is what I wanted to do initially anyway. Make sure two-sided works. Oh yeah, I think these were flips, unless I missed my guess. Yeah, there we go. Nice. And yeah, it has to be two-sided. Alright, now we're talking. So we've got some density volume that we've marched through here. We need to polish this up. And then we'll have to look at our light march steps. So basically, let's make it more expensive, right? Whereas we march some number of steps for density through the volume, which is what I was drawing over here, right? We have to march some lesser number of steps to the light source to properly shade it. And we're doing that in our clouds out here. So we can pretty much copy the algorithm for that. And you can kind of see that we get shading and shadowing on the clouds. Especially from underneath them, you can see that the lighting is important. We're also, for the nebula, we're going to want to integrate light color into it and some other shit as well. So, we got our little smoke ball here. Let's change our scale. I guess we could just go ahead and expose it. What's up? Do like 8. Alright, so far so good. What's up, dude? We're working on some nebula volumetric stuff. We're basically, just to catch up the people who just hopped in, we're kind of adapting this cloud atmosphere shader that we wrote a while back to try and make some like space nebula effects. So this is using raymarching to basically do a shell of clouds as well as the atmosphere with like our shadow, halo, and scattering and all that good stuff. So I want to be able to do some like volumetric space dust / space clouds, things like that. And so I'm going to be kind of working on a similar idea to this, but actually simpler in practice than this is. So we've written this quick HLSL function right here that we're working on. Go ahead and update our code over here. That is just basically we do a ray sphere intersection given parameters of the object that this material is applied to. So in this case, we're passing camera position, world position of the surface, light position that we're not using yet, actor position, object radius, a volume texture to sample density from, and then a scale. So our scale is controlling how big, or I guess how dense our noise texture is here, right? And we'll need it to be pretty big to avoid tiling. Just trying to get a baseline set up here. I don't know if I'll get to the light marching yet, or the composition of everything yet. But if I can get like a good baseline to work on over the weekend, I would be pretty happy with it. Yeah, it's I don't necessarily plan on this ever like becoming a thing. It's just something that I have fun doing, you know? Like I just do this for fun. It's a bunch of math that takes me months to process and figure out, and that for me is just like a good time. Another thing that I've been working on is like the waveforms here, which is still needs work, but we got like shoreline directed waveforms. Wave crest masking needs work, as well as I need some modulation of the effect versus just the regular Gerstner wave ocean stuff. But if we go into wireframe, this is all based on a custom quad tree implementation I put together with a third-party plugin called Real-Time Mesh, which lets us basically generate our mesh in real time. So you can kind of see Like, it took quite a while to put all this together. Um, I don't have like the the goal of this for me is closer to like a sim or like a fantasy sim, something along the lines of like a space engine. So I'm really interested in like procedural generation, and I really like the idea of large scale, extremely large scale procedural generation that is like seamless. So like without having to do like load screens or anything. So like this is planet scale, right? But I have another part of the project. If I load this over here, which I'll have to run to actually see it. Um, but this part of it generates things at universe scales, but there's a lot of hackery that's required to make that work in practice. Oh, I'm gonna have to do it in sim mode actually. I mean, I guess we could fall for pretty much ever, but we're gonna want to be in sim mode for this. Simulate. And we're gonna need to go very fast. Faster than that. Alright. So now we're moving at like intergalactic speeds. So this is like a spiral point cloud generator and a asynchronous octree, basically virtual positioning system, right? So each one of this is not complete. It's a work in progress, but each one of these dots, these big dots, would represent a galaxy, and I've only spawned procedurally one galaxy around this one, right? But there's nothing really stopping you from, based on a certain distance, fading this out into just a placeholder and spawning another one on the one that you're getting close to. And then likewise, I can select any of these individual stars or points in the overall octree. And if I can slow it down enough to actually be able to manipulate the camera fast enough. And I could spawn placeholders to hook in like planets and stars and things like that at this level. Now the precision isn't working here. It's not like, there's definitely mad precision errors right now. But the idea is the idea is that it's like basically works on this idea of virtual coordinates and treadmilling. So imagine the sun is here, the earth is here, and you're standing right here on the earth, right? The sun to you right here looks this big, right? It looks this big in your field of view. But say the sun was actually right here. Well, as long as you didn't move from where you were at on Earth, you wouldn't be able to tell that this sun was much smaller than this sun. Because like in your field of view, it looks the same, right? And actually, let's do at about 50% because that's going to be easier for illustrative purposes. So now you got a sun at half size that's 50% closer, and you can't tell that it's moved at all, right? But if you were to start, if you were to start moving towards it, you would quickly realize, hey, the sun that I thought was this far away is getting closer to me way faster than I thought it was going to, right? Okay, so what can we do about that? What if, when I move towards the sun, at whatever speed I'm moving, the sun is moving away from me at half of the speed that I'm moving. So now, when I'm halfway to the sun, right here, and I would normally be able to tell that it was getting closer too quickly, but now the sun has also moved by like a quarter of the original distance, and it's right here. And actually, what ends up happening is you can't tell that the sun is a different distance from you. You get there if it's moving 50% of the rate that you're moving. You would arrive at the surface of the sun at the same point at which you would have anyway, right? So why is that important? So the idea of containing an entire universe inside a single scene that doesn't have any load screens is actually impossible given the precision of the math on the computer. But what you can do is you can render everything in a bubble that's about the same distance away from you, but you can have the bigger stuff that's further away treadmilling away from the player faster than the player's moving towards it, or not faster than the other things, right? So like a star might only treadmill away this far, but a galaxy might treadmill away much further, right? So the whole idea is that there's like this relationship. Yes, exactly. So the whole idea is there's this relationship between. Oh yeah, there's all kinds of there's all kinds of issues that have to be solved, but like the basic idea is that you chunk the world using an octree, and the octree can hold the relationship of the scale of everything without having to necessarily hold the precise positions of everything, right? Because it's in a very deep octree, say like an octree that's 80 levels deep. So I'm not sure if you know what an octree is, but it's basically a spatial structure where if you have a cube, well, like a quadtree, you would divide a square into 4 sections, and then you would divide each of those sections into 4 sections, etc., etc. And larger things can occupy higher levels in the octree, whereas smaller things can occupy smaller levels in the octree. And the way you can determine what level to insert it into is based on the smallest subdividable unit. Let's say you want your smallest unit to be a meter. Then you need to figure out how many levels of an octree you need, what depth of a tree you need to go, which is powers of 2, that you need to go from 1 meter to the size of the universe, right? And then you can figure out, okay, what level would a galaxy be approximately? Okay, we're going to insert just a voxel core at that depth representing a galaxy, and then when you get close enough to it, we're going to procedurally generate a galaxy on top of that voxel core based on its randomized data. And you can do that for everything. And as long as you're within a close range of it, we can maintain a reasonable amount of precision. And then when it gets far enough away, you're doing the virtual coordinate system, like treadmilling away. So that's like the overall idea of what I want to do, or what I'm working towards. But I have been on the I want to create a planet rabbit hole for a very long time, because it took me a long time. It took me a long time to get from I want to build a planet. I'm going to make one with a material that you can only see from space, and you can't actually land on. To yep, we're too fast. We're moving in universe scales. Hold on, we'll get there. Oh god. Still too slow. There we go. So my first attempt at this was I built a planet with just materials that looked okay from space, but you couldn't do anything with it. You couldn't land on it or anything like that. And it took a pretty long time to go from that to here's a planet that I can just spawn in on and walk around on, right? Oh, god damn it. Let me turn the music down. Smidge. Alright. Yeah, so it took me a while to go from that to here's this planet that you can walk around on that generates the mesh in real time, that has a reasonable level of precision, that has an ocean, that has an atmosphere, that has spherical gravity. Um, that all took quite a while. And tonight I thought I would just kind of relax and do something a little bit simpler, working on just a kind of a dumbed down version of the atmosphere shader to do nebulas with. Yeah, it is. Is like I made some playlists for myself to play in the background while I do stuff that won't get me copyright struck. This one is Warhammer based. Fought a lot of against the engine. So I'll say, actually, with 5.4, introduced directional gravity. Not super intuitive to build, but it actually helped a lot. I didn't do the gravity until 5.4 came out, and I used their system along with their pawn to do that, and that wasn't too bad. And then the mesh generation. So like the mesh generation you would definitely fight against the engine if you were trying to use the baseline engine assets. But I use this plugin called Jesus Full-Time Mesh plugin. You can find it here. And this is a whole can of worms, but we can take a look at the guts of it, which is this generate mesh data function. So using this plugin, it wasn't too bad. There was a pretty steep learning curve. This is all just generating mesh data, right, for a given quadri node. So I wouldn't say I had to fight against it too hard, but I did have to use a third-party plugin to be able to get the mesh to render fast enough. I could probably increase the speed here as well with some compute shader stuff to do some of this heavy lifting. But I got it to a point where like it's pretty much fast enough. I mean, again, if I switch it to wireframe, we can kind of see the rate at which the updates are happening is pretty quick. I would love it. I'm still too fast. I would love it if it was and then the rest is using Fast Noise 2 library to generate the actual landscapes. So we basically came up with a noise formula when I was making some planet materials. Let's see if I can find them. Yeah, so I came up with a noise formula that generates some pretty convincing planets. And I converted most of this into Fast Noise 2 formula, with the exception of some of the river generation here. I haven't done that yet. I was actually refactoring my noise formula. But there's like certain like conceits when you're generating noise to like make a planet texture, or not a planet texture, like a planet landscape, where there's some ways that you can combine noise, some rules I came up with that can do a pretty good job of replicating like terrestrial planets. So one of the things you can do, if you just have like a random noise, right, it's not going to look very good. But what you can do, you can run certain filters on that. So I don't know if you heard of like billow noise or ridge noise, but it's basically running a noise value that goes from like 1 to -1 through an absolute value filter. And that'll give you a ridge kind of like this. And you can then kind of stretch that, giving you landscapes that look like this, which is sort of like a fault line, So you can use a large scale of this to generate some fault lines. You can then invert that and domain shift it off to the side a little bit, and that'll create some mountain ridges. And then if you can figure out a texture to render or a noise combination to render individual mountain peaks, you can then multiply that with your ridge and you can get mountain ridge lines, which unfortunately is not configured right now in this, I don't think, because I was refactoring, so I don't have the mountains in here. But like, let's see, hang on, I might be able to switch it back in. Show you what I'm talking about. Planet actor. Yes, this is Planet Noise Generator 3. 2. If this doesn't work, I'm just gonna let's try to redo it. Yeah, that was just the continents right there that you were just looking at. The one here is closer to what I want the end product to look like. I mean, obviously without the glowing water, but you can get an idea of kind of what's going on here. So there's a few different layers at work here. Like I said, you generate a large scale continent layer that follows kind of plate tectonic-y effects by faking it with noise, and then you flip that and you basically raise it to a power to isolate the ridge lines, and then you offset those to create mountain ranges, and then you do something kind of similar to generate valleys, which can then carve out riverbeds, and you kind of get a cool effect that looks a lot like an actual planet should look. And the other noise formula I had before, the 2, 3 is in progress, 2 is like semi-complete, looked better, so let's try that. Alright, so let's try a different seed to force it to regenerate. Okay. This song's a little intense, like, they can't all be hits. Hang on a second. Let me get something a little bit more chill. Alright. Blended attributes, mesh parameters, seed. Oh. Well, it doesn't seem to have updated, so I have to figure that out. But, yeah, so it's a shame. I'd like to show the feature with, like, mountain ranges and stuff like that, but oh well. Probably not tonight. And so back to what I was actually working on is just this basic volumetric raymarched doodad that I intend to use for nebulas. Okay, too much. Still too much. Let's just get rid of that. Right now we're just doing a single noise texture, but this will probably be a combination of several noise textures in the end. Oh good, I appreciate it. I have fun showing this shit off since I spent so much time bashing my face against it trying to get it to work, so Don't worry about it. It's no sweat. So what we're gonna want to pull in now is I have fuck. I broke something. There it is.
Dandy cars, wild landscapes, expeditions bold. Through the traps and hazards, treasures to behold.
This is without the
In the shadow of Elder
combination here, so we could actually probably increase this. Let's double it, which makes sense. Also, okay, I got it. So first of all, this is wrong. Our maximum step count should not just push us to the radius, it should push us to the diameter. Okay, that makes more sense. Because like if our maximum step size is based on the radius, then we would only ever be able to if we're looking straight in, we would only ever be able to go this far into the we would only be able to raymarch to the halfway point. We need to be able to raymarch at a maximum the entire diameter of the sphere. All good, dude. Appreciate it. Have a good night. I'm probably not going to be on too much later anyway. I've basically accomplished what I set out to do tonight. I do want to check and see if I can pull in the light march step from this. I have too much windows open with too many complicated materials. It's not happy with me. So I'm going to actually close this one after I lift this function out of it. Gotta think. So we have this max steps. We're gonna probably want like max light steps. Do 8. We might be able to get away with we have a light position as a global value? Yeah, we do. So we can, okay, got it. So let's try it like this. We'll do
With an endless cry, Liliana
just thinking.
the darkened sky.
So how do we determine? I need to draw it. So if we have a light source here, and we have a ray going through our material like this, and we have a sample position on our ray here. God damn it. Can't draw. We have a sample position here. How do I determine? It's gonna be another sphere intersect, I think. So we need to run a second sphere intersect from here. And we need to determine this point. And then we need to divide this by the light steps. And then we accumulate our light density like that. So, okay. So that means we need another ray intersect. Ray sphere output. Light intersect. Ray sphere intersection. Position, that's our sample position. We gotta find our light direction. Light direction. Center radius. So that's gonna give us what we need. Then we can figure out our step size by max distance equals. Our step size should probably be calculated the same way we were calculating it in the density, maybe. I have to think about it. But we can definitely get our distance, which can be the distance or length. I don't remember the HLSL. So this is the distance of. I think it's length actually. Length of our position minus our light intersect, and since this should always be inside the sphere, our position, we can just assume that we're inside. We shouldn't need a check, so this should always be intersection position 2, I think. And then for now, we'll just say our step size is max distance divided by max light steps, which is probably not going to look right, but there's definitely going to be other, yeah, so light direction times step size. Okay, find density sample. Okay, so this is, where's our sample density function? Right here.
He stands unwavering by a solemn pledge. With every strike, every
figure out that part. Position, radius, times. Noise scale.
He stands unwavering by his side.
Total density, there we go.
With every strike, every stand he makes.
And this is going to return a float 3 as well now.
Unbreakable vow in the trance's light. Giving strength, shining so bright.
Okay, maybe not. So take it back. Because we need to be able to do the exponential function with it. So
in the call of the brave, he never dies. A warrior of light, a guardian so true. He can
just do this. Float density equals density sample x times y times z. Okay. Wait.
In the chronicles of magic, his guiding light. Unbreakable vow with an endless.
And then this.
In the hero's place.
We're gonna need to add a new field, so we'll say float darkness threshold 0.5 for now. Oh, we can't define it like that. We have to do nf dot darkness threshold equals 0.5. Alright. Darkness threshold. And then one more.
From the fields of Zendikar to the battle's edge, he stands unwavering by his solemn pledge.
Something like that. And then, hey, it compiles at least. Nf dot up. Say 0.7. And we'll fuck with all these later. And then we're going to need to look at our other function and figure out how we combine these two.
With a pulse of honor and a shield so strong, he leads the charge where heroes belong. From the fields of hope, his spirit flies in the call of the brave. He never dies. A warrior of light, a guardian so true. Gideon's journey forever new. To remember Gideon with his unyielding light. In the chronicles of magic, his guiding light.
Cloud atmosphere.
With an endless grace, Gideon Judah in the hero's place.
Need to figure out how it's compositing the light, basically. I'm gonna want this.
In the rhythm of hope, his spirit flies. In the call of the brave, he never dies. A warrior of light, a guardian so true. Gideon's journey forever new. In the rhythm of hope, his spirit flies. In the call of the brave, he never dies. A warrior of light, a guardian so true. Gideon's journey forever new.
Yeah, so light transmittance, we calculate with the light march. Yeah, so we're gonna have to do this basically. But for now, I think I'm gonna call it here. This is good progress.
A city of secrets where stories unfold. City of guilds in the techno trance beat. Ravnica's rhythm alive in every street with a pulse.
Yeah, we don't have to worry about like this is actually a lot more complicated because we're talking about marching through a sphere, but what the atmosphere shader does is it actually marches through the shell formed by two spheres. And you have to worry about all kinds of edge cases.
From the heights of the Azorius to the depths of the cruel, each guild has a part, each follows its rule. With every deal struck, every
like say your camera starts here. Oops. Starts here. Starts here. Starts here. Starts here and goes this way. You have to like account for a bunch of extra conditions that was challenging to figure out, whereas with this one that we're working on right now, we really only have to worry about camera starting here, camera starting here. That's it. We don't have this extra shell logic where we have to do two different marches, one for this segment, or actually that one you wouldn't have to, but for some of these you would have to do like a march for this segment and a march for this segment, and then you have to add it together and things like that.
City of guilds with an eternal trance. Ravnica's story in the endless dance. Across the land. Across the land. Across the land. In the lives of the Azorius to the depths of the cruel. Each guild has a part, each follows its rule. With every deal struck, every battle fought. Ravnica's legacy in power.
Let's just get this cleaned up a little bit. To properly combine light and whatever it is.
Ravnica breathes with an electric surge, with fires of promise and shadows of old. A city of secrets where stories unfold. City of guilds in the techno trance beat. Ravnica's rhythm alive in every street. The pulse of magic and the clash so grand. The heartbeat of Ravnica across the land. From the heights of the Azorius to the depths of the cruel, each guild has a part, each follows its rule. With every deal struck, every battle fought, Ravnica's legacy in power wrought.
Format it all so that it doesn't trigger me.
Ravnica's rhythm, alive in every street, the pulse of magic and the clash so grand. The heart
This is a pretty good starting point to build on over the weekend.
lights of the night, the city glows in the dance of the guilds. Its power flows, a symphony of conflict, a harmony of strife. Ravnica's essence, the dance of life. City
can kind of see the slices here, but we can actually offset that with a blue noise texture, which we do in the atmosphere. So we can basically change our step size very minorly based on the pixel that's being sampled from, or the world position, as like a seed. And then we can kind of get rid of these slices. It'll introduce a little bit of dithering, which it might be able to show it, but it's not very perceptible. Yeah, I'm not even sure you can tell, but alright. Yep. I'm 7. Damn, dude, you've been up late. Yeah, likewise, I'm about to get in bed. So later. See ya.